So in the 6 days class, what we have seen at the end, that there may arise some cases where your PD, whenever you are trying to characterize it or classify it, you can find that the discriminant is actually not a constant, such that you can confidently characterize the discriminant as hyperbolic, parabolic or elliptic. Rather, you can find that your discriminant is actually a function of some x, y, and that is some independent variables, and that's why you have to locate some locations, or so you have to partitionize the whole xy plane into separate spaces for where from where you can find that somewhere it is elliptic, somewhere it's hyperbolic, etc. So we will check say with a new problem. This is given as, just give me a minute. Say this problem, you are given that there is a PDE that is 2 So for this PD, we will find that the b square minus 4ac, this is 4 minus 4 sine square x, that is 4 common 1 minus sine square x, that is 4 cos square x. Now see, when if x, first point to be noted that this is a square term, so this cannot be negative, so there is no chance to have any elliptical cases from here. And if x is not equal to 2n minus 1 over 2 into pi, then if x is equal to this, then this is equal to 0, so you will be having all parabolic equations. But if x is not equal to that, then your cases are hyperbolic. So you have to classify in such a way. Next problem. See, for this problem, your b square minus 4ac is equal to x minus y whole square, and which is of course greater than 0 if you are not on the x equal to y straight line. So if this is not, then this is true and the equation is hyperbolic, and if y is equal to x, then this is equal to 0, so you are at a parabolic case. So say for this problem, if you are told to find out the canonical form and solve, what we have to do? So first we have to distinguish the different cases. So suppose the first case is y is not equal to x, then we will see that dy dx is equal to either 1 or x over y, and solving that we can have y minus x is equal to c1, that is, this is equal to the first characteristics, and the next one will give us y square minus x square is equal to c2, that is eta is equal to x comma eta is a function of xy, and combining them you can find that a bar is equal to 0, b bar is equal to minus 2 x minus y square, c bar is equal to 0, d bar is equal to 0, e bar is equal to 2x minus y. Check them whether I am writing correctly or not, and then incorporating them in the PDE given, you can have the changed one as and changing x, y to xylon and eta, you can write it as But the point is, this can be written as del xi of xi del u del eta, and integrating that, first integration will be with respect to xi, so that will be del u del eta into xi is equal to a function of eta. And if you integrate once more, you will have u is equal to 1 over xi f of eta d eta plus g of xylem, another arbitrary function of integration. So from there, if you write your xi is equal to x y minus x and eta is equal to y square minus x square, you have solved your equation already. But well, if there is an integration,